So far in our projects, we've been working with what's called resistors, things that resist electricity, or in other words, they hold back electrons. That sounds kind of cool. And these resistors are very tiny, and their different values are indicated by the color bands, as we described in one of the notebooks or lab books. Right, so this orange-brown one is a 330. So what's inside these resistors are kind of a combination of conductive material, so things that conduct electricity, and non-conductive material, things that resist the transfer of electricity. And that blend will determine how much it resists the flow of electrons. What we're looking at in this experiment are called variable resistors or potentiometers. Right, so this is one example of them. When we look at other equipment like musical instruments or volume knobs, they're much bigger. They all have the same general principle. They vary the resistance. And let's just look at a quick demo of that. So here I have the fan from the kit and a potentiometer, and it's hooked up to my power supply. Let me just kind of move over so you can see those connections. And I have that connected to 5 volts. Let me just turn on my power supply and jiggle the, or move the potentiometer. I think maybe you can hear it. Now let me really turn it up louder, or faster rather. Okay, so that's what a potentiometer does. It varies, it's a variable resistor. And let me just illustrate this in one other way. So here I just have a piece of paper and a few pencils. And what I'm going to do is kind of create a variable resistor. Color this in, or not color, it's pencil. Okay, well, let's call that good. And now I'm going to put my meter so it's visible, and just so I can illustrate this. So here, when my connectors or my probes aren't connected, you can see it's a 1, and when I connect it, it's a 0. So let's try this. You can see it changes as I move out. I guess I can get to all right, and let me just give one other illustration of this. So here I have an LED. Let me hook it up to my power leads here. And I have this blue LED now, and you can see it's bright. And then as I move away from it, it gets dimmer, so it's a variable resistor, that pencil line. And then I can get it bright again. Cool. Okay, and let's see how this works. So I have my potentiometer pushed into the board, and now I'm going to hook it to the Arduino. So the first thing I'm going to do is just get power to the board. These are kind of long. Hold on one second. So I have the black wire going to 5 volts, or I'm sorry, so I have the black wire going to ground and this yellow wire going to 5 volts, and I'm just going to kind of poke them in the standard place on the rails. All right. Now what I'm going to do is hook them up to the potentiometer. Now there's 3 legs in the potentiometer. Let me see if I can show those. So there are 3 legs in the potentiometer, and the 2 outer legs, one's going to be connected to ground and one's going to be connected to 5 volts, and the middle leg is going to be connected to one of the analog in pins, as I'll show you shortly. So going to our thing here, I'm going to go from negative to one of these, to one outside. I'm going to go positive to the other outside. That looks great. And now I'm going to have a wire go to analog in. So the middle pin here is going to go to one of my analog in pins. And let's say analog 0, why not? So let me just kind of zoom in on that. All right, so let's hook this up to the laptop and see what we see. Okay, and now that we've hooked up that potentiometer, let's see how we can use it in code. So here we are at the Arduino IDE, and let's set, just using good programming practices, let's set a global value equal to where we hooked up that potentiometer. That was at A0. So all the analog inputs on the port, on the board, start with that A prefix. So it's A0. All right, so in setup, let's just print the values of the potentiometer. So in setup, we're going to need to do serial begin. Okay, that's about it. And in loop, let's get the value of the potentiometer. And it's not like a button, which is just on or off. The reason it's called analog is it can take a range of values, right? So it can be, it's just not 0 and 1. It's actually 0 to 1023. So let's read that. Let's call it potentiometer value. And instead of digital read, we're going to use analog read. It's connected to an analog pin, A0. We're going to read that pot. Pot equals A0. And then let's print that value. Whoop. And let's delay a bit. For good programming practices, let's define how much we're delaying up here. Let's say it's every second. And that's it for our small program. So the potentiometer is connected to A0. We set wait to be 1000, which is 1 second. We initialize the serial connection, 9600 baud. And then in the loop, we get the value of that potentiometer. We read it into a variable called pot value. We print the value of that variable, pot value, and we wait 1 second and do it again. The reason I'm waiting is we don't want to see the Arduino is super fast. It would just be printing things nonstop to the screen. This just kind of slows it down a bit. Okay, so let's go ahead and save that. Let's stick it in our Arduino course. And let's create a new folder because this is experiment 3. And then let's save this as initial. Sounds like a good name. Okay, and let's go to the serial monitor. Okay, now it's printing the value there. Okay, let's try changing the potentiometer here. So I'm just going to move it in one direction. And it's 0, 95. I'm just turning it gradually here. 178, 280. I'm just slowly turning it one way. And it goes from 0 to 1023. So this potentiometer goes the full range. Sometimes potentiometers aren't like that. So you'll have to, it's useful to use the serial monitor just to see what the range of your potentiometer is. So that's cool. And if you see that, man, I'd like to be able to turn it kind of counterclockwise and get to 0, and instead it gets higher instead of lower, just reverse the positive and negative of the potentiometer. So if it is contrary to the way you'd like it, you just need to reverse that positive and negative. And I'm fiddling around here. All right. So suppose now we would like to vary the speed of an LED based on that value of the potentiometer. So let's see how we can do that. So I've connected an LED to pin 13. And we have to initialize that LED. So we're going to say pen mode LED output. And here in this loop, I want it to be, so if the value of, when we read the analog, if it's 200, we want the LED to blink 200 on and 200 off. If the value is 500, it'll be 500 on, 500 off. So that's very simple to do. Let's just continue getting that, or printing that value. And in this case, I want to turn on the LED, right? We're just doing a simple blink. And now this delay won't be the standard 1 second here, but it'll vary depending on what we read. And again, if the potentiometer reads 100, we want it to delay 100. Well, we hold that value, that 100, in our variable called pot value. So I can just simply put pot value here. And I'm going to turn off the LED. And if you can probably got this one right, it's going to be pot value again. So what we do here is we read the value of the potentiometer and store that in value. It'll be 0 to 1023, some value. We'll store it in pot value. Then we'll print the value of pot value, so whatever the potentiometer is. Turn the LED on, wait that amount. If it's 100, it'll wait 100. And then it'll turn off the LED and wait that 100. We move the potentiometer a bit. Now pot value is 500. It'll print 500. It'll turn on the LED, wait 500, turn off the LED, and wait 500. So let me give that a shot. Let's upload that. Move to the serial monitor, and now we see it's blinking 1 second on, 1 second off. And let me adjust that. That's a little faster. Now we're getting into the blinking faster mode. And let's see if we can get it. It's still blinking, but we can recognize that it's blinking. At some point, it's just going to look like a steady. It's blinking so fast we can't detect it. Right there, it's still on. Oop, but it's just kind of hard to read. All right. So let's make this a little more interesting and say, well, we don't want it to be, once it gets that fast, we don't like it, and we'd like it to only blink if the value's over 100. Let's get to that. So that looks good to us, but if it's less than 100, we don't want it to blink. All right, so how would we do that? So if you're thinking, wait, he's already used the word if, so we probably need an if statement, you'd be correct. So let's see what that would be like. So it'd be something like only blink if the value is over 100. All right, if pot value is over 100. So let's see if we can manage that one. So if pot value, whatever we set that to be, is greater than 100, then we're going to do the blinking. And keep in mind that we don't need, it's going to be off otherwise, and the reason we don't need to put an else and turn it off is that always at the end of a blink, it's already off. So keep that in mind. If we had wanted the LED to be on versus off, then we would need an else with an off. I don't know if that made sense, but go with me on that one. All right, let's load it up. Let's look at the values. So it's blinking fine. And now let me reduce it lower than 100. And it stops. And I just get, oops, over 100 and it'll start blinking again. All right, so that's kind of the scoop with how to program or how to use this potentiometer. You can see it's relatively straightforward. We really haven't introduced much new programming. Let's take a look at what we did introduce. We showed that when we connect something to an analog pin, we use the A prefix in front of it. And the other new thing was using this analog read. And everything else we know how to do. So nothing is new here other than those things. When we connect an analog device, we connect it to an analog port, and we specify those with the A. I think I've repeated that about 5 times now, and we're using analog read. And that's about it for the new stuff. So I hope that was helpful. Take care. Bye.